Hey everyone, welcome. You know, if you've ever stared blankly at a page of algebra and felt like you were reading a completely foreign language, well, you hit the nail on the head. You actually are. Today in this explainer, we're going to completely demystify algebra. We're going to treat it exactly like what it is, a beautifully structured, constantly evolving mathematical language. We'll strip away all that abstract mystery, right? We're diving into the real, mechanical tools that make it tick, from its ancient roots all the way to how it runs on that fancy graphic display calculator sitting on your desk.
All right, let's take a quick look at our roadmap for today. We're covering the origins of algebra, the language of letters, expanding and simplifying, the art of factorizing, substituting values, and finally, rearranging formulas. Let's jump right in.
Section 1. Origins of Algebra.
To really get algebra, you first have to meet this guy. This is Abu Ja'far Muhammad ibn Musa al-Khwarizmi. He's widely celebrated as the literal father of algebra. Born way back in the year 790, he worked in Baghdad when it was home to the greatest university in the world. Imagine that! Around 830, he wrote this totally groundbreaking book, and it's actually from the title of that exact book, specifically the word al-jabr, that we get our modern word, algebra. Pretty cool, right? And get this, not only did he map out quadratic equations, but he's also the very same scholar who introduced the Hindu-Arabic decimal system to the rest of the world. A true game changer.
And honestly, this history just brilliantly shows the human touch behind the math we do today. Take the poet and mathematician Omar Khayyam, for example. While he was working on these incredibly complex theorems, he used the Persian word for thing, which is shay, just to represent an unknown quantity. Over centuries of translations, mispronunciations, and mathematical evolution across Europe, that simple word for thing eventually morphed into the famous universal variable we all know and love today, the letter x. It's literally just a placeholder for something.
Section 2. The language of letters. Let's see how this alphabet actually works.
So here's the absolutely crucial takeaway. Algebra isn't just some random collection of symbols designed by math teachers to confuse you. No way. It's actually a really precise grammar. The letters simply stand in for numbers we either don't know yet or numbers that can change depending on the situation. Now, using algebra might seem incredibly intimidating at first glance, but honestly, it's just like learning Spanish or French or Japanese. The more you speak it and the more you practice its fundamental rules, the easier and more intuitive it all becomes.
Section 3. Expanding and simplifying. Let's look at our first set of mechanical tools.
Okay, let's start with expanding brackets. The golden rule here is actually incredibly straightforward. When you're removing brackets, absolutely every single term inside that bracket must be multiplied by whatever is sitting right outside it. It's just systematic distribution, sharing what's outside with everything on the inside.
Check out how a condensed mathematical phrase translates into a longer expression here. If you have a 3 sitting on the outside and an x plus 4 on the inside of the brackets, well, you multiply the 3 by the x to get 3x, and then, don't forget this part, you multiply the 3 by the positive 4 to get a positive 12. So 3 times the quantity of x plus 4 becomes 3x plus 12. Boom! You've just successfully expanded the sentence.
But as you know, sometimes sentences just get a little too wordy, and that's exactly where simplifying comes in. Think of it like editing a really messy paragraph to make it punchy. Simplifying cleans up an algebraic expression by simply combining identical types of terms. So if you've got a long sentence with, say, 2 separate x terms, or maybe a couple of xy terms, you just add or subtract their numbers to combine them together into one single neat term. Keep like with like, and you're good to go.
Section 4. The art of factorizing.
If expanding an expression is like breathing out, factorizing is like breathing in. Visually, we can actually prove that factorizing is the exact mechanical reverse of expanding. While expanding destroys brackets by multiplying, factorizing brings the brackets back to life by dividing terms by whatever they happen to have in common. Take a look at 10x plus 15. Ask yourself, what number goes into both 10 and 15? Well, the number 5, right? So we pull that 5 out, open up our brackets, and we're left with 2x plus 3 safely inside.
Now listen up, because here is the secret to getting top marks on your exams. The one rule you absolutely cannot forget is that you must always identify the highest common factor. For example, if you look at the expression 6x plus 2x squared, the highest common factor isn't just the number 2, and it's not just the letter x either. It's actually 2x. You need both. Extracting that full 2x and placing it completely outside the parentheses, that is what it means to factorize fully.
Section 5. Substituting values. Let's see how we translate letters back into real numbers. You know, in the old days, you'd have to write all of this out by hand.
painstakingly. But today, we have modern graphic display calculators. Whether you're rocking a Casio or a Texas Instruments model, these devices have a bunch of dedicated memory channels built right in. You can actually store specific concrete numbers into these channels to represent your variables, like A, B, or C. Then, you just let the calculator do all the heavy lifting of substitution for you. It's a real time saver.
Let's see how this actually builds a final result. Imagine you're handed the expression negative 2a plus 2b minus 3c. If you're told to substitute a equals 3, b equals 4, and c equals negative 5, well, you just plug those exact values into your calculator's memory banks. Then you type in the original expression, hit equals, and your calculator will confidently return the number 17. Why? Because negative 6 plus 8 plus 15, yep, that equals 17. The calculator takes the grammar, applies the vocabulary you gave it, and spits out the perfect translation.
Section 6. Rearranging formulas.
Finally, let's talk about rewriting whole mathematical sentences. The subject of a formula is literally just the letter that sits all by itself on one side of the equal sign. So in the formula, A equals 2B plus C, A is the star of the show, right? It's the subject. But what if we already know A and B, and we desperately need to figure out what C is? Well, rearranging allows us to logically shift the entire formula around to isolate whichever variable we happen to need.
The secret here is all about balance. To make C the new subject in A equals 2B plus C, we've got to get that 2B completely out of the way. And we do this by carefully performing the exact same operation to both sides of the equal sign. In this case, we subtract 2B from both sides. That logically shifts the formula around. We end up with A minus 2B equals C, which is of course the exact same thing as saying C equals A minus 2B. See what we did? We made C the subject without breaking the fundamental mathematical truth of the equation.
And there you have it, the whole shebang. From the grand ancient universities of 8th century Baghdad, all the way to the digital memory banks of your graphic display calculator, you now officially possess the foundational grammar of algebra. You know exactly where the letters come from. You know how to expand and simplify them, how to factorize, substitute, and rearrange the whole puzzle. So the only question left for you is, how will you apply this universal language to solve the unknowns in your own life? Keep practicing that grammar, and we'll catch you in the next explainer.